Have you ever faced challenges when your application could not handle certain spikes in traffic? For example, your application receives more requests, more traffic for a specific period of time, and your application could not, auto scale it off. So I'm curious about how Kubernetes can help you, avoid the waste of resources and reduce infrastructure costs. If you said yes, you are definitely in the right place. Hi everyone, I'm Zoran Sari. I'm CNC Ambassador. In this session, we'll dive into an essential topic for Kubernetes users, scaling applications in Kubernetes using the horizontal pod autoscaler. So, as you can see, I've already pulled up this page from an official DigitalOcean documentation page, and we will explore about what the HPA is and how it works, and like real world examples, like hands on with their probably mostly like uh, scaling, how it works and all, so custom using its custom resources. So basically, uh, before diving into that, let's understand HPA. It's like, in Kubernetes, it automatically updates workload resources such as deployment or stateful set, squaring the workload to manage the demand, right? That you said, maybe, for example, your CPU resources or your memory request, right? So, horizontal scaling means that it's just with adjusting replicas for application ports, whereas we have another one like vertical port scaling, which deals with resource requests and limits for containers within ports. So, for example, again, if the load increases, like your the request coming from outside or anywhere inside port to port communication, where your the load increases, the request traffic increases, right? And the number of ports is equal to the, you know, configured replicas, number of replicas, right? For example, it has set to something one, right? Then HPA will instruct the workload resource to scale it up to number of two replicas or like a maximum number of replicas. So we don't know like how many numbers. We have to like deal with that, like how we can set that. So we'll come into that, all those hands-on experience. But yes, if the load decreases and the number of ports is above the configured minimum. So, for example, you have said to something, it has said to like number of replies, let's say three. It is like minimum, more than minimum. That means you have three instances running on, and the load decreases now. So SPA will instruct the workload resource to scale back it down. So how cool is that? So HPA will do all the things. We don't have to worry about their waste of resources, as I mentioned, or infrastructure costs. So how did it all works together? It is just all things, has something related to algorithms that runs behind that, and it also deals with the target threshold value, and your with the average resource utilization, and if the target threshold is reached, then HP will scale up your application deployment to meet the higher demands. If below the threshold, this will scale down the deployment. So that's how this HPA works and deals with that. If you do want to deal with that, all those in a detailed way, you can definitely follow the documentation from Kubernetes uh, website. So how those like algorithms and all, and let's we'll dive into basically with their features. Like we'll have to go through their something Kubernetes metric server. which works by collecting resource matrix from kubelets, exposing them via Kubernetes API server. I think we have one architecture diagram where you go. I think if you have to understand from this, like matrix server is stored, in the cluster. It collects CPU, memory usage matrix from kubelet running on each worker node, right? Whereas you have application deployment, which also runs on like worker node, so which has got n number of replicas. So if we don't know about like how it scales up and down, so we have custom resource application HPA. This fetches matrix like CPU, memory usage via matrix API, and matrix API gets exposed to Kubernetes API. So this is basically where this Kubernetes matrix server aggregates resource usage data for all ports, and yeah, so everything comes into this one place, like where uh, like based on the matrix and threshold, SP decides whether to scale up or scale down, right? So again, get to the prerequisites. We need to have Git client installed. We need to have Helm chart, Helm CLI for managing metric server, CDs, upgrades, and kubectl and all things. Now let's start with installing Kubernetes server. So here is my terminal, and I have my Kubernetes up and running. And let's install this using this link, which will install this in our uh, Kubernetes cluster. Let's me let's see how it's has to do with kubectl and Helm. So since I have already installed and it is now up and running, this is the state. So we are using kubectl way to do this, installing this and all. So basically, we can go with this repository, but for this case, I'm using my own. So I will again back and forth with go back and forth with this with their configurations file. So we don't want to worry. We don't need to clone this for now. So let's see how this application looks like. I think this is not that comes into space. Um, we're looking for uh, like their custom resource, how this looks like for example, this is part of one of the application, the deployment application configurations. So we are defining like scrapping those matrix based on resource, that is deployment one, and the name of the deployment, which is related to particular namespace. Then we can define the namespace here. We're setting the minimum replicate as 1 and max is 3, and metrics coming from this resource, which is scrapping from CPU, which targets utilizations as threshold as 50%. So I believe this is all about this. And let me see if I missed something here. So we may use the kubectl autoscaler command, to create HPA custom resource, or we can directly create YAML manifest, then use kubectl to apply changes. Right. So first, let's deploy an application. Maybe this is the URL here, and see how this looks like. This is where this application defined, which has image box and resource limits and CPU defined as like this. So where is command and generally running just echo test and sleeping for a few seconds, and it is for every time it is you know going test. So which will, I think, it will overload the resource and CPU resources, and it will surpass the threshold value. So again, let's deploy this application on our Kubernetes cluster. Here we go. Let's see. It's deployed now. It's created. You can see the application from here. So here it's creating the container. Anyway, you can go ahead and create the HPA using this imperative command. Let's go ahead until it running. You can auto scale up, auto scale using this. We have to keep sure, make sure that deployment name is the same as that we have deployed now, and we are putting off the threshold as 50% and minimum as maximum 1 and 3. So here you go. It is being created now. We can also look for that. So there is nothing to worry. As you can see, this showing the target by 50% is unknown here. As you can see here, uh, like um, this shows for a while, and whenever the average CPU utilization hits 50%, it will deployment scales it up, gets scaled up by 3 replicas, no less than 1 replica. Let's see in action. Maybe I have missed that. So you can see now the maximum ports and the replicas has set to 3, and while it was 1, it was showing 0, but it had to be 1 anyway. Uh, if you want to go ahead and see the custom resource, we can go and find this, like how this works. Like here, just taken like the current status, as you can see, but uh, apart from that, everything looks similar, right? Like the target utilization, type utilization, and the scrap target reference. Nice. So now what I want to see, like number of ports for that deployment set. You can see the number of ports has increased to 3, and everyone is running. So that's pretty much about this part uh, of this tutorial. I guess you have learned so far about HPA, kind of making it easier for us. Everything like scaling up and up, and sometimes when your logic is this going to make it down. So we'll export one more scenario, like we'll have this constant load where this is talking about you have Python code implementing like performing some CPU intensive map computation, like running the for loop for thousand times, and it is squaring of with some mathematical calculation. So let's begin and run this application on our Kubernetes cluster. So if I go here in this git and look for that, I believe this is one we will be dealing with. You can see this is the deployment where we are running Python. run Apple Alpine image, and within that we are running the entry point of sh. I believe this is defined inside config. This is where we were running the same, mathematical calculation implemented using Python. So let's deploy this to our cluster and see it in action. So I don't want to miss anything. Like they're scaling this application in an action. So now we have to create HPA, but we can use from their kit. The anyway, we are saving our time, so that's why we are using from their kit here and suit in action. This can do the same, which we just dealt with that first scenario that we are doing with one of the application. So I will go ahead and apply these changes to our cluster. Uh, it has some issues with the version. Anyway, we can modify this for a while, but let's deal with that pivotal autoscale command to run through this deployment. I believe the name of the deployment has been set to constant load deployment test, and we'll add this name here. So it has been created, I believe. So I have to uh, get the code in action, like how this going to increase number of replicas set as maximum. There you go. So few of others are getting created, and others are in pending stage. Since we know the number of the sorry, the threshold has been uh, has been set to 50%. So where this has increased to 253%. So basically, this is where like HPA instructs the workloads to scale it up. I hope this is now in the other port is up and running. So there you go. We have explored how the HPA can automatically adjust your application resources, making your Kubernetes clusters more cost efficient. And from understanding its components to implementing best practices, you now have the tools, match your application scale seamlessly under fluctuating workloads. Uh, Definitely, we had some other scenarios we can deal with that, but respective to time, we are uh, doing this for this up to this point. Of in our next video or next session, we'll delve into other scenarios as well, and we'll explore the Prometheus adapter. So as you implement HP in your project, remember always monitor your metrics closely, test your scaling policies in different scenarios, iterate and refine as your application grows, right? So scaling is just about handling traffic. It is about ensuring a great user experience while optimizing your resources effectively. Thank you for joining me today. If you have any questions you'd like to see covered right in future sessions, feel free to reach out. Until next time, happy scaling, Kubernetes.